Hello again. In this chapter, we're going to start looking at web services and SOAP. We'll start by explaining what a web service is, and then the two big jargon terms in web services, and these are SOAP and something called a WSDL. That will give us what we need to know about the general concepts behind web services, and then we'll be ready to look at how web services work in Java. In Java, the library we'll be using is called JAX-WS, and by the end of this chapter, we'll have written our first web service using this library. So let's start with the basics of web services. In this course, we'll be using the employee management project that we built in the first module. So the point that we've now reached is that we've coded a server-side service. We have an employee management service that offers functionality to clients. In Module 1, we built a client to access the service. We've been simulating the client running on a different computer to the server. Now that's not quite true for us when we're testing because we're using the same computer both for the client and the server, but that doesn't really matter because the client and the server are running on different Java virtual machines. So WildFly has had to use network calls, even though we're on a single machine, to make the call across the wire. We've been relying on some magic for this to happen, because we didn't write any networking code at all. The call between the client and the server was using Remote Method Invocation, or RMI. This has been a key feature of EJBs since their original inception. Remote method invocation is where a Java object on one machine is able to call a Java object on another machine. And by another machine, I really do mean separate physical machines. The computers could be located thousands of miles apart as long as they are on a network, of course. It's called RMI in Java, and to be honest, it's not that special because it's built into the standard edition of Java. It's been there since, I think it was version 1.1. You may have coded some RMI yourself, and it's not too hard, but there is a restriction with RMI, and that is that the client's object and the server object must both be written in Java. And this is where EJBs come in. EJBs feature an enhanced form of RMI where the clients can be non-Java. The name for this, by the way, is the horribly named RMI IIOP. Now, I can't even bear to tell you what that stands for because it's simply not illuminating. But of course, if you want to put this into your favorite search engine or find the Wikipedia page for RMI IIOP, you'll find out what it stands for. So it's a horrible name, and it's based on an old standard called Corba. But this means that our clients can be written in languages other than Java, such as Visual Basic, C++, and so on. Well, that's great, but it turns out that this underlying mechanism that's based on this old technology called Corba was so complicated and difficult that it really didn't catch on. We thought it was going to be the biggest thing in the early 1990s, but it really fizzled out. If we did want to write, say, a Visual Basic client calling our EJBs, we would have to have a really good understanding of Corba, and it would be a lot of very hard work. So while this feature is okay in EJBs, something much better came along in the late 1990s. In fact, it was popularized in the early 2000s from outside of the Java community. But it solves the same problem of communicating with a server using any programming language. It solves it, however, in a different way. And this was added to JavaEE at some point in the early 2000s. Well, you can probably guess that this technique is called a web service. A web service, then, is a technique for exposing our server-side code to remote clients. Perhaps the main feature of a web service is that the server and the clients can be written in any language. We could have implemented the server in Java and have the clients written in Visual Basic, and the client code wouldn't even be aware what the server code was written in. Let's have a look at a very simplified view of a web service. Now, if you've worked with web services before, well, you'll need to bear with me because I'm going to simplify enormously here. But I think it's useful to get this as the essentials of what's really happening. So what I've got here is a client. Remember, this client could be coded in Visual Basic, in Java, Delphi, Python, whatever language you can think of. And we also have a server located thousands of miles away from the client. And again, the server code could be written in Java, .NET, Fortran, I really don't care. Let's say, for the sake of argument, that the service happens to be written in Java and it's our old friend, the employee management service that's running on the application server. It didn't have to be, it could be any code from any language. But in our example, our client wants to invoke the business process called getEmployeeById. Given the client and the server are in different languages and possibly running on different operating systems, how can the client possibly invoke this process? Well, the answer is in two parts. First of all, the client is going to send a request to the server using HTTP. Now, this is the standard web protocol, and since it's a worldwide standard, most languages can use HTTP. We know that whether the client is using Visual Basic, Java, Python, or whatever, it will be able to send data across an HTTP connection. Now, a quick digression. If you have worked with web services before, you might know that it doesn't have to be HTTP. It just has to be any well-recognized transport mechanism. But I want to go for the simplest possible concepts, and I would say most of the time the protocol that we're going to use to communicate from client to server will be HTTP. Now for the second part. We need to send a request to the server, and we need to send parameters with that request. The request is going to be in the form of what I'm going to call a message. And I'm calling it a message because we're not really invoking a method on the server. The language on the server might not have methods, so we have the more neutral concept of a message, and the structure of that message isn't going to be some kind of complicated binary format. By the way, Java's RMI does use a rather complicated custom binary format. In web services, we usually use a very simple XML document. Well, I say very simple, actually it's complicated, but at least the format being XML means that the structure is reasonably simple. Now I've got an example on screen here, which is a heavily simplified example, but I hope it'll get the idea across. This is what an XML message might look like. You can see in the XML message, I've got the name of the operation that I want to invoke, which is getEmployeeById, together with the data that I'm going to send across to the server. In this instance, it's the ID of the employee that I want to retrieve. This format is completely neutral and it looks nothing like code that might be making a method call. Whether the server is Java, VB, or whatever, it really doesn't matter. And actually, the client doesn't care either, as long as they can send this XML document to a URL via HTTP. That's all the server needs to be able to worry about. When the server retrieves this message, it can unpack it and do some processing. So our client is going to send this message to a server. After a while, the server will respond with the resulting data back to the client, and this will again be in a neutral format, for example XML. The example might look like what we're seeing on screen right now. And then all the client would need to do, whatever language it's written in, is it has to unpack this XML message and interpret the results. It might be worth saying that the name web service is a little bit misleading because this really hasn't got anything to do with the web whatsoever. There's no browser involved here. The client is just arbitrary code. The whole thing is a technique to allow standalone clients to access your services on your server. The web part of web service just comes from the fact that we're using HTTP to connect the client to the server, just like a browser does, but that's all the name means. And as I pointed out earlier, you don't have to use HTTP, you could use other protocols. Now you might be thinking, why do we need to do this? Why would we want to write the server code in one language and the client code in another? Surely it's just easier to stick with Java, but that would be missing the point of a web service. The main usage of a web service is for interoperability. We might want to build our server code in the language of our choice and then allow third parties, maybe partner companies or our customers, to be able to access our services in the easiest possible way. Our third parties will have their own preferred language, and it would be terrible if we had to say to them, you must use Java. So web services allow us to decouple our clients and our servers, giving freedom to both sides. A good example of a project that might want to use a web service might be, for example, an insurance company that might want to allow their partner companies to resell their policies, or an online bookstore that wants anybody to be able to query their catalogue using custom code to write fancy software to boost their sales. And that's exactly what companies like Amazon offer. But even if you're building applications completely in-house, you might still want to use web services if you're building client-server applications. Java is rarely used these days to build client applications. I think really because other languages such as Visual Basic or maybe really the .NET framework are much better for building Windows applications than anything else, and so it makes sense to be able to build a Windows application using .NET, but if that application needs to interact with a server and the server's running Java, well, Web Services gives you the technique to do it. So how do we create web services in Java? Well, before we get to that, there are two jargon terms that we need to define. And the first of these is SOAP. It's a nice sounding name, but really this name is just the term for the technique, or if you like, the protocol that we've just defined. The idea of sending some standard XML structured messages using HTTP. The term, by the way, was originally coined by a team at Microsoft who designed the first web services. It originally stood for Simple Object Access Protocol, but today it doesn't stand for anything. It's just a silly name, a bit like Windows XP was. I guess they had to drop the acronym because I don't think it's technically a protocol, and it's certainly got nothing to do with objects, and that's the O and the P invalidated. And it isn't simple either, as you'll find if you go much further with SOAP. In particular, the messages that I just illustrated with the simple XML are actually far more complicated. They're called SOAP messages, and they must follow a standard structure, which is horrible. We're going to have a look at a real SOAP message later, but perhaps an even more important jargon term in web services that we should know about first is WSDL, which is normally pronounced WSDL. It stands for Web Services Definition Language. So what is a WSDL? Well, the problem is that we need a way of telling our clients what operations are available in our service, or from a Java developer's point of view, which methods in our EJBs we want our clients to be able to call. Remember that the client will not be able to see any of the Java, so without some kind of a system in place, the client wouldn't know that they can call, for example, getAllEmployees, registerEmployee, and so on. And also what parameters are required for each of these method calls. The clients wouldn't know that when calling getEmployee by ID, they need to pass a string representing the ID in the XML message with a particular parameter of ID. Now they might be able to guess that, of course, but I'm giving you a very simple example here. In a more complex method call, there'd be no way to guess what the parameters are. So I suppose we could write a user guide in a document form and email it to our client coders, and they could work it out from that. But in web services, we have a more formal and automated process. The WSDL is a definition of the services that are available on the web service, together with the specification of the input messages and the return messages. In other words, it's a contract definition that tells the client how to invoke the web services. And again, since we want to be completely language neutral, the WSDL is defined in XML. Now I've got on screen here a heavily simplified example of a WSDL. If you've come across WSDLs before, you'll know that they're really much more complicated than what you can see here. But don't worry, because before long, we will have a real WSDL and we'll be able to see what they look like in full. I've tried here just to explain the general concept of what's inside a WSDL. So web services, as we know, work around the concept of messages. These are the XML documents that are sent to and from the web service. So peeking through this XML here, we can see that there appears to be a message called getEmployeeById request, and that appears to have some kind of parameter defined inside it called ID of type integer. By the way, bear in mind that web services and SOAP are completely unrelated to Java, so the types that you see here are in fact XML types defined by the XML standard, not types defined by Java. A second message is the getEmployeeById response. So this appears to be the XML document that's going to be returned by the web service. And that appears to contain two parameters, a first name which is a string and a surname which is a string. Now I've omitted the rest of the contents of this message just to keep the XML block here quite short so it's easy to read, but in theory we'd have here the entire structure of the object that we're returning to the client. And then at the bottom there's some information that explains how these messages can be used. Web services use the term port to denote a related group of operations. If you think of the port as just being your entire web service, actually you won't go far wrong for now. So here we've defined a port or a web service called Employee Management Web Service, and it's going to have at the moment just one operation called getEmployeeById, which accepts an input message which we've defined as being the getEmployeeById request message, and an output message that will be returned to the client of getEmployeeById response. So I hope that what you're seeing on here makes some kind of sense. As a client coder that's trying to interpret this WSDL, it's telling us that there's an operation called getEmployeeById. If we want to call that operation, we need to prepare a document that looks like this to send across, and we should expect to receive back a document that looks like that. Actually, they're not that nice to read, but they're not really meant to be human readable. The idea of a WSDL is that we can feed this WSDL into the programming language and then let our programming language work out the details of what it needs to send to the server. The really great thing about web services is that the infrastructure required is very simple. If we're coding the server, all we need to be able to do in our target language is to be able to accept requests from HTTP and to be able to read and write XML documents. Now our job in this chapter, and we're finally getting to the point where we're going to be able to write some code at last, and I'm sorry that we've had a long theory talk first, but our job now is to make our employee management service become a web service following the SOAP standards. Well, we could go off now and write an XML parser and decoder, we could create the WSDL by hand following the standards of SOAP, and we could somehow program maybe a Java servlet to accept the HTTP requests. All of that is simple enough, but it would take a lot of work, it would take a long time to do, and it would be low level and, to be honest, really low value work. And so this is where, at last, JavaEE comes in. The library for handling SOAP-based web services in Java is called JAX-WS. Another one of Java's great acronyms, it stands for the API for Web Services. Well, I should say this is for SOAP-based web services because since SOAP was invented, there is now a second style of web service, and we'll be studying that a bit later in this module. The JAX-WS library is purely for SOAP. It's actually part of standard Java now, so you don't really need WildFly to make this work, but it's very tightly integrated with JavaEE and EJBs and all of the topics we've covered on Module 1 of the course. JAX-WS is really simple to use, or at least at first. We're going to create an EJB and give it an extra annotation which is @WebService. Actually, as we'll see, we need to make some changes to our code, but the web service part is very simple. So let's go to our code in Eclipse. I hope you're going to follow along with me at this point. And the first thing we're going to do is create a brand new EJB, which is going to be our web service EJB. And I think we'll put that in the employee management package. I'm just going to expand this out. So we'll create a new class here. So we'll call the class Employee Management Web Service Implementation. And I'd like this class to be an EJB, so let's give it the @stateless annotation. And then we need to put in some methods here. I think for now we'll just create the getEmployeeById method. And that's going to take an integer parameter called ID. And I'm going to worry about the implementation of this method in a little while. For now, let's just return a null. And let's also create a method to get all the employees. So that'll return a list of employees. And we'll call it getAllEmployees. And again, for now, let's just return a null. So we'll need to import the different objects to make this class compile. I'm just going to do that with Control-Shift and O. And it's a Java util list. What we've got here right now then is a standard EJB, nothing special at all. I'd like to make it into a web service, and we'll do that by using the annotation at the top of the class here, @WebService. We'll need to import that annotation, so I'll just do a Control-Shift and O again. That's been imported, and that's all I need to do. Now, obviously, we haven't yet written any code here, but by adding this annotation, then when we deploy the class, WildFly is going to generate a full implementation of a web service for our example Employee Management Web Service EJB. It will handle the conversion of the incoming XML messages sent by the client into Java. And when we return data, like the list of employees in our getAllEmployees method, well, the corresponding XML return message will be generated for us for free. Let me re-emphasize, we're never going to have to generate any XML ourselves, and we're not going to have to interpret any XML ourselves. It's an amazing amount of magic that we are getting, by and large, for free. Now, we will need to write some code here to implement these two methods, but that's standard Java code. There's really nothing different we need to do in this EJB compared to any other EJB. It's simply adding this one annotation @WebService, which does all the work for us to make this into a web service. Now, don't get too carried away. When you have more advanced requirements, if you have some very complicated Java objects to deal with, then you might have to do some manual intervention to get the XML correct, but we're going to get a lot of mileage from this simple default behavior. Now, I can add an optional parameter to the web service annotation to give it a name that I want the web service to be called by. This employee management web service implementation makes sense in my project, but it's not a very friendly name that I might want to give to clients. It might be more sensible to just tell clients this is the employee management web service. So let's use the optional parameter of the annotation to do that. And the parameter is name. So we simply do in brackets, name equals, and then in quotes, employee management web service. So this is looking good. Now, you might be thinking that I could have added this annotation, the @WebService annotation, to my existing EJB class. If I remind ourselves, we created one earlier called Employee Management Implementation. And I could have added the @WebService annotation to this class. This would have avoided the need to create the extra class. But I recall in an earlier version of this course, our first JavaEE course here at Virtual Pair Programmers, this actually caused a problem due to a bug in one of the other application servers. At the time, we were using Glassfish, and a newer version of Glassfish that came out after the course was released had a bug in it, which meant that didn't work. So although it should be safe to do that, it doesn't always work, and it's better, therefore, to make sure it's safe to keep your web service EJB completely separate from EJBs that are going to be used for other reasons in other ways, such as through RMI. Also, of course, it's not necessarily the case that we want to expose all of the methods in this EJB through our web service. So by providing it as a separate class, we can provide a wrapper that exposes only those methods we want to. Notice that I'm exposing getEmployeeById and getAllEmployees, but I'm not exposing the registerEmployee method, or at least not yet. So my wrapper class is preventing that method from being called by a web service. So we have two methods here. How do we implement them? Well, we've already got the implementation in our employee management implementation EJB, and in fact we know that our web service class is really a wrapper for that EJB. So what I'd like to do, I think, is inject this EJB into our web service EJB, and then I can call its methods. So let's have a go at doing that. The first thing we'll need then is to have a private variable to reference our employee management implementation EJB. Well, we need to reference, of course, the interface for that EJB, which was called Employee Management Service. So we're going to have an instance of Employee Management Service, and we'll call that service. And because that's an EJB, I want that to be injected in, so we'll add to that the @inject annotation. We'll just import that annotation. Okay, that's looking good. Now, unfortunately, this isn't the complete job. It won't be very efficient to do this. Now, the reason why is that if we go and look at our Employee Management Service interface, we'll see it has the @remote annotation. Now, we're using this EJB as a local EJB, so we don't want Java to have to create this using a network call. With the remote annotation, that's what's going to happen. So what I'd like to do is to be able to get an instance of my employee management implementation, but using the local version, not the remote version. Well, that's actually an easy problem to fix. The way to do it is to define a second interface that's like this but has the @local annotation, and we'll make our EJB implement that as well as the remote version. So what I'm going to do then is create a new interface, and I think we'll call this one Employee Management Service Local. So we want the local interface to have exactly the same methods as our remote interface, which is this one here. So I'm going to copy out the 3 method definitions and paste those into our new interface. But then the whole point of this is this needs to have an @local annotation. Okay, now that we've got that, we can say that the implementation of Employee Management Service can also implement Employee Management Service Local. So let's go to that implementation, and we'll say as well as implementing Employee Management Service, it's also going to implement Employee Management Service Local. Now I'm just going to save that, make sure that's compiling. It looks like it is, so that's good. Well, then now in our web service implementation, rather than injecting Employee Management Service, we want to inject Employee Management Service Local. So having done that, what's going to happen is that the same class is going to be injected into our web service. We're going to get an instance of Employee Management Implementation, but because we've requested the version from the local interface rather than the remote interface, there'll be no unnecessary network calls. It'll be straightforward for Java to inject this as a local, simple Java object. You might be feeling a little uncomfortable because what we've now got is 2 interfaces so that the EJB can be injected as a local EJB and instantiated remotely from our client using RMI. And 2 interfaces with the same methods, I agree, it's not ideal. We've got 2 versions of code to maintain, but I think this is not a situation that would happen very often in a production system. I think it's unusual to want to use the same EJB to be instantiated in these 2 different ways. If you do want this kind of setup, then you might want to re-architect the system. I think what we would do to get around that problem is go to our remote version of the interface. Let me just find that here. And say, rather than defining the methods here, let's say that it extends the local version. Okay, and I'm not going to do anything else in here, but the project should still work. It's a little bit more complicated, so let me just talk through what we've done. Thinking purely about the RMI version, the remote method invocation, our implementation class is going to be injected somewhere, and it's going to be injected using the interface Employee Management Service, which is a remote interface, which really is a wrapper for Employee Management Service Local. It's extending the list of methods, but it's not actually making any changes. That's absolutely fine. But when we come to web services, it's the local interface that gets used, and that's absolutely fine as well. And what we've managed to do now with this structure is we've avoided the code duplication. So it's a slightly complicated structure. If you need to pause the video and just recap this, then please do. But when you're happy, we'll be able to move on and start building in the code then that makes our web service work. So here's the web service code, and let's start with the getAllEmployees method. What I should be able to do now then is to delegate to the service object that we've injected into here. So we can return service dot and call it getAllEmployees method. That's all we need to do. We've created the wraparound. Now, unfortunately, I've been working with this getEmployeeById method, but I don't think I've actually created that method in my employee management implementation. I think what we'll do is leave that for now. We'll get this working, and then we might go back and write that bit in a few minutes' time. For now, we've got enough done that we can deploy this to our server. But before we can deploy this, well, we need to upgrade our build script. At the moment, our build script is creating a jar file, but web services need to be deployed not as jar files, but as WAR files. If you've not come across WAR files, these are web archives. Actually, it's a very similar concept to a jar, but the structure is slightly different. It's designed to be deployed to a web server, such as Tomcat, and it can contain code that can be run by a web server, such as Java servlets. We actually don't need to know anything about WAR files really for this course. We just have to be able to build and deploy one. So to do that, we need to update our build.xml file. And actually, we'll need an extra file called web.xml as well. I provided you with some examples of both of these in the starting workspace for this chapter. So the easiest thing to do is to drag the web.xml file into our project, and this needs to be at the root of the project, not in the source folder, so we'll just let that go there. And we'll take a copy, that's fine. So you should see it here at the same level as your build.xml. And rather than replacing the build.xml file, if you open the version that I've supplied, which is a complete build.xml file, but copy everything below this line. If you remember, this is the line that you need to edit to work on your system because it includes the location of the deployments folder. So if we take everything from below that line down to the bottom, just going to copy that, close up the text editor, and then in our project, I'm going to replace everything below the line that configures our destination of the deployments. We'll paste in what I've just copied. We'll save that. That looks like it's okay. I'm not going to spend any time going through this build.xml file. I'll leave you to read through it if you want to. I'll perhaps just point out we've got a new section called WAR, which is going to be built. It's going to be called employeemanagement.war, and it'll be saved in the same folder, our deployments folder. And if you look down here, you'll find there's a section here called WAR that tells Ant what it needs to do. Well, I'm not going to say any more about it because this isn't a course on Ant, but what I will do is run this build script. So let's just do that. Okay, so that looks like it's worked okay. Let's just have a look at the server console to make sure there's no errors. I can't see any there. So I think what we'll do now is go and have a look at the web interface for WildFly. And I've got that up here. And what I'd like to do then is go to the Runtime tab, Subsystems, and this time we'll choose Web Services and click on View. Well, I hope you can see here that we've got a web service. Actually, we've got what look like two web services. That's because we've got the files both in the jar file and the WAR file. The process of doing our build has created both of those, so it's been duplicated. You don't have to worry about that. They've got different contexts because they've come from different file names. We're only going to use the top one. Obviously, in a production system, you'd alter your build script to exclude that from the jar file. I haven't bothered, and it's absolutely fine to have that duplication. But we're interested in this top one here. So I've just selected the top one here, and then I'm going to click on Attributes. And what we can see here then is it has the URL here for the WSDL. And in the URL, you can see it's got Employee Management Web Service. If you remember, that was the name parameter we gave to the annotation of web service. That's what the client is going to know this web service as. And as you can see, the WSDL URL has been generated for us. And if we click on this hyperlink, we'll actually get to see the WSDL in XML. Now, because of the browser that I'm using, you can see that I've got a little bit of extra information here at the top. You don't have to worry about that. What we're looking at here is the full WSDL for this particular web service. This has been generated for free. We didn't have to do any work. JavaEE or WildFly has done this for us simply by us adding in the @WebService annotation. Now, I did say in the introduction that WSDLs are not very pleasant. Well, here's the proof. What we're seeing here is, well, a very long document. If you can scroll all the way down to the bottom, you'll see there's probably around about 100 lines of XML here, just for our very simple web service. But I wonder if we have a look through, we might be able to pick some things out. Here we've got an operation called getAllEmployees, and it's saying that the input message is called getAllEmployees. The output message is getAllEmployees response. Let's try and find the getAllEmployees response message. Here it is. Well, this isn't what I expected to see. We would expect to see here a list of the different parameters of an employee, and there aren't any. That actually tells me there's a problem with my code. We'll have to go and look and find that and fix it. Let's do that now and then regenerate this WSDL. So what's the reason why my WSDL doesn't know what the parameters are for an employee? Well, let's go and have a look at the employee class. That's in our domain package. Well, looking at this, I can see we've got no get or set methods. So actually, these private variables aren't exposed. The only thing that a client would be able to see if it could get hold of this employee class is the constructor and the toString method. That's pretty useless. So let's go and create the gets and sets, and I think we'll get Eclipse to do it for us. I'm going to select all of them. And then let's redeploy this now. I'll just save that first. And we'll see if that's changed the WSDL. Okay, so there's no errors on the build. We'll just check it go through on the console. There's no errors there. Okay, that looks like it's finished. So now if we go back to our web interface, and I could actually just refresh this page, but I think we'll just refresh the page before, first of all, to make sure that our URL hasn't changed for the WSDL. It shouldn't have done. So that's going to be in runtime. And then we need to navigate down till we find web services. We'll select the one from the WAR file and go on to attributes. There's our WSDL URL. It hasn't changed. And now if we find the message for retrieving an employee, and it's here, look, we can see it contains a first name, a job role, a salary, a surname, and you can see there's the XML variable types here of integer and string. So this WSDL has been built for us automatically, and it means we can give our clients this WSDL and they can use it to start writing their code. Now we'll learn how to do that in the next chapter. But before we close off this chapter, I think it would be useful if we did have an implementation of our getEmployeeById method. So I'm afraid we are going to have to go and put that in. Now, it's a while since we wrote the code here, but this might be a good chance for you, if you wish to pause the video and write that code yourself. So we want you to implement getEmployeeById. I suggest you implement it in the employee management service, and then you can delegate to it. Pause the video and give that a go. Or if you don't really want to do that, you can either watch the video now where I'm going to implement it, or you can pick up the code at the end of this workspace and just replace your code with that version if you'd rather. All I'm doing is straightforward Java coding to get this method to work. So I think what I'm going to do for this is start at the JPA level and work up. So let's go then to the package which has the data access, that's down here. And our starting point then is going to be the interface employee data access. And what I'd like to do is put a new method in here. And we'll make it an abstract method just to be consistent. It's going to return an instance of employee, and it'll be called find by ID, and we'll pass in an integer of type ID. Now that I've saved that, we should find that our code won't compile because where we've implemented employee data access, we'll find that that method hasn't been implemented. So I can see there's two places now where it doesn't compile, our production and our testing version. Let's go into the production version then, and we'll provide an implementation for this method. So I'm going to get Eclipse to create the method stub for us. And then the code that we'll need to do in here, well, I think what we'll do is start off by creating a query. And that's going to need our entity manager. We'll call create query. And the code that we need in here then, the JPL to retrieve an employee based on its ID, is going to be select employee from employee, and we'll call it employee, where this time it's employee.id is equal to the parameter that we're going to pass in of ID. We obviously need to set that parameter. So this time it's going to be called ID, and its value is the ID that we are passing into our method. And then what we should be able to do is to return the queue.getSingleResult. That should bring back a single object. We will need to cast that into an object of type employee. And I think that should be okay. We'll need to implement something in the testing version. I'm really not bothered about that version. So just to get this to compile, we'll add the unimplemented method and just make it return a null. We'll leave that as it is. Okay, so that should deal with implementing it at the data level. Now we want to add it into our service. So we'll start with the interface for the service and add in here a new method. And we'll call this one get by ID, passing in an integer type, of course, of ID. That's fine. Now we'll see, of course, that our implementation doesn't compile because we haven't implemented it there. So let's go and implement it in the implementation. And we can now simply then delegate to our DAO, return DAO dot, and I can't remember what we called it, find by ID, there it is. Okay, so now our implementation is fine. We should be able to go then to the web service. That's where we actually wanted this. And we've now got a method in our service that we can delegate to. So we can return service.getById. Okay, so that was a little bit of a diversion, a little bit of coding, but now at least we have two methods that should work. Let's just deploy this and we can have another look at our WSDL and check that that looks okay. Okay, so the build's complete. We'll just check the console window. There's the new version being loaded into WildFly. And then finally, we'll go to our console. And I think I'll just refresh now my WSDL URL. We know it hasn't changed. And then on the new version, what we can see is we've got, here's the employee definition, and it uses this thing called a sequence. If we find get employee by ID response, and if we find the get all employees response type, that's down here, look. Well, in that sequence, this time we've got an unbounded maximum. So that will be a list of these employee elements. It's a complicated structure, but I think we can now see the WSDL looks correct. So we should be ready to code up our client, and we'll be doing that in the next chapter. I'll see you there.